Alrighty, for our last lesson of the chapter, we are actually going to be solving radical equations. And whenever you do a radical equation, so you're always going to want to check the solution, okay? So always, always, always check your solution. We don't do it with everything, but with radicals we do. So what we're going to do first is isolate the radical. So get the radical by itself. It already is here. If I look at this one, the radical is not by itself. I'm adding 2, so I would need to subtract 2. Okay? So the first thing I'm going to do is square both sides. So the reason why I want to square both sides is because a square undoes a square root. So I get x minus 5 equals 9. And then I'm going to solve for x. So add 5. So I get x equals 14. Let's check our work. So off to the side here, I'm doing a check. The original problem was this. Does this work? So I put a question mark above when I'm checking my answer. So here's the little check mark for check. 14 minus 5 is 9. Does that equal 3? The square root of 9 is 3. 3 equals 3. So I can come back over and box my answer. Okay? Next one. We are going to have to isolate this absolute value. Not absolute value, square root. So I'm going to subtract 2, subtract 2. Okay, why am I subtracting 2 and not dividing by 2? Because your 2 is being added to that, so you have to undo that. So I get square root of x plus 1 equals 6. Then what do? Oh, cool, we square both sides. Great. So now I have x plus 1 equals 36. And then I am going to subtract 1, and I get x equals 35. Okay, so before I can box that answer, I'm going to come over here and do my little check. You always check with the original equation, so 2 plus the square root of 35 plus 1, does that equal 8? So 2 plus, simplify the radical first. 2 plus 6, does that equal 8? Yes, as a matter of fact, 8 does equal 8. Great. Okay, now we're going to move on to the next one. Okay, let's do it. Alright, so we're going to do just square both sides. So be very careful. This isn't 10 times 2, this is 10 squared. So I get 2x equals 100. Divide both sides by 2. So I get x equals 50. Okay, so before I can box this answer, I need to do my quick check. Square root of 2 times 50, does that equal 100? Square root of 100, does that equal 100? Sorry, not 100. Does it equal 10? I squared it, and that's why it equaled 100. Alright, square root of 100 is 10. Yes, 10 equals 10. Alright, next one. Let's keep going. So this one, I'm going to subtract 9. So this 9 minus square root x minus 2, this 9 is positive. If I want it to go away, I have to divide by a negative. Sorry, if I want it to go away, I have to subtract 9. So I end up getting negative 5. And then I'm going to divide both sides by negative 1 because I have to isolate the square root. So I get the square root equals 5, and then I'm going to square both sides, and I get x minus 2 equals 25, and then I'm going to add 2 to both sides, and I get x equals 27. Okay, so the computer may have just run out of juice and I had to go grab my charger. So you might need to copy some of this down, and I'll just repeat. We are checking our solution right now to make sure that the solution is a valid solution and not an extraneous solution. So when you're doing this, like I said, you're just going to follow your math step by step. Square root of 25 is 5. And 9 minus 5 is 4. 4 equals 4. So that does work out. So now I'm going to go back and box that answer. 27. Okay. Let's see. What are we working with now? Solve the radical equation and check the solution. So that's big tip in any standardized test when it says check the solution. They're literally telling you to check your work when they normally don't. So I would always check my work if I saw that one. So I'm going to square both sides here. The reason why I'm going to square both sides is because this radical is isolated. It's by itself. So the square root is undone by the square. So this is just 3 minus x. However, on this side, we need to be really careful because we can't shower the power. And the reason why we can't shower the power is because a puppy would die. Aside from that, here's another way to help you remember. You cannot shower the power if there's a plus or minus sign here because those are each individual terms, and then you would have two people in the shower, right? So no go. So no showering the power. What you have to do is FOIL it out. So you have to be really careful with these. So let's go ahead and FOIL it out. I'm going to get x squared minus 2x plus 1. So you can FOIL it out. Obviously I can do this stuff a little bit in my head. Hopefully I don't make tons of mistakes. But I've been doing this a lot longer. So that allows us to get x squared minus 2x plus 1. And then because I have a square, I'm going to get everything away from the other side so that it can equal 0. So subtract 3. And I'm subtracting 3 because I want that to cancel out. So they have to be opposite signs. And then I'm going to add x. Okay? So then I get 0 equals x squared. And negative 2 and positive 1 makes negative 1. And then 1 and negative 3 makes negative 2. So I'm just going to write this. I just flipped it. So all I did was take the left side, or the right side, and make it the left side, and vice versa. So now I have 3 terms. So I have to t-chart this. So we have x and negative 2 and 1. Because negative 2x and x are make negative x. So it's just like a compilation of everything we've been doing now. So the new step was squaring both sides. From there it should all be new, or all be review. I think I need to go to bed and get some sleep. So anywho, I get x equals 2 and negative 1 from that one. And yes, we have to check both of these, but I think now that you've seen a visual check on each of these, let's do a kind of mental check. So what I want you to do is plug in each one. So this is going to be 3 minus 2 because the x equals 2 equals 2 minus 1. So I've plugged in that 2. Okay. So 3 minus 2 is 1. Does the square root of 1 equal 1? Does 1 equal 1? Yes. So 2 is a good solution. Let's check negative 1. 3 minus negative 1, does that equal, oh, I forgot those. Does that equal negative 1 minus 1? So 3 minus negative 1 plus plus, that's the square root of 4. Does that equal negative 2? Does 2 equal negative 2? No. So that means that solution didn't actually work. So our answer is just x equals 2. Yay, these are fun. I love them. Keep going with them. Alright, no trickiness. We'll check for our extraneous solutions. So I'm squaring both sides. Get 5x minus 9 equals x minus 1 times x minus 1. How nice. We already did the math for that up there. You see that box method up there. X squared minus 2x plus 1. Alright, it's quadratic, so we got to get one side equal to 0. So subtract 5x. Oh, I get to add 9. Those make 0. Okay, so again, I'm just a fan of the variables being on the left side. You don't have to do this. It's really just an extra step, but whatevs. You do you, I'll do me. I felt like I was going to come up with a rhyme there, but I didn't. Negative 5 and negative 2, because this is positive and those are both negative. Alright, x minus 5 times x minus 2. So I get x minus 5 equals 0 and x minus 2 equals 0. And moving on up. So x equals 5 and 2. Okay, so now we're doing our little check here. So we go back to the very original problem. Even though I have squares on there, I'm doing it without that. So I have 5 times 5 minus 9. Does that equal 5 minus 1? And then on the flip side over here, 5 times 2 minus 9. Does that equal 2 minus 1? Well, let's find out. That's 25, and 25 minus 9 is 16. Does that equal 4? Why, yes. Yes, it does. So 5 is a good solution because that's what we had plugged in for our check. And then here I have the square root of 5 times 2, which is 10, minus 9 is 1. Does that equal 2 minus 1? Why, yes. Yes, it does. So I get that both of these are good solutions. So it's not always going to eliminate one. Both of those are actually great solutions. Alrighty, let's move on to the next one. What do you notice that's different? Whoa, there's a cube root. We're okay. So we're going to do the same thing. We're going to isolate the cube root. So be careful because that cube root is still negative. We haven't done anything with it. Sometimes you just go so fast that you miss little things. And then now we're going to divide out the negative 1 because we need to isolate the radical. This is a cube root. It still needs to be isolated. So it equals 3. And then we're going to cube both sides. So I get x minus 1 equals 27. Add 1, and I get x equals 28. Alright, let's do our check for that. So I have space to do a big old check. So 7 minus the cube root of 28 minus 1, does that equal 4? So 7 minus the cube root of 27, because 28 minus 1 is 27. Cube root of 27 is 3, and 7 minus 3 is 4. So that one works. So sometimes students say, oh, if it's this, it's going to check out, and if it's that, it's not going to check out. You always check, because there's not really any rhyme or reason, because if there was, somebody would have come up with it. Alright, what are we doing on the back side here, guys? Oh my gosh, oh no! There are rational exponents. So rational exponent just means fractional. We kind of talked about this before, and you've probably written on at least one of your notes for me, but rational just means you have a fractional exponent, okay? So what we're going to do is we have one way or the other way, okay? So I like to show you both. This is the traditional way to approach a problem like this. So if you have this, because this is to the 1/2 power, if we made it go to the sorry, I can speak, it's fine. If we square it, then what will happen is we get x plus 6, multiplying fractions, no big problem, top times top over bottom times bottom, which is just x plus 6 to the 1st power, which is what we want, because if it's to the 1st power, then we know it just equals x plus 6, and we can subtract 6, and we get x equals 10. And then we can check it. Look at, watch this. What's 10 plus 6? 16. And 16 to the 1/2 power. Remember, 1/2 power is square root. Square root of 16 is 4. So the check works. So we get x equals 10. Now I promised you a different way. So some students see this x plus 6 to the 1/2. And they're so used to converting it that you can do that. Just do it. X plus 6. And then it's to the 1/2. So power over root, which is just the square root of x plus 6. And then I square both sides. So I get x plus 6 equals 16. And then I subtract 6. And I get x equals 10. Alright? So we've already checked it. So there's your answer for that one. So you get to decide what you want to do after this for the other ones. I'm going to do it both ways just because I like to be super thorough. Okay, so again, I would raise that to the second power because that's going to make that fraction reduce to 1. So I just get x minus 1 on the left, but then I have to FOIL this. Okay, so I get x minus 1 equals x squared minus 14x plus 49. It's quadratic, so get one side equal to 0. So I get x squared minus 15x. I'm rearranging it at the same time. Equals 0. Then I'm going to t-chart that. So I'm not going to show the t-chart. You guys know how those work. It's going to be x minus 10 times x minus 5. And then split set, see what you get. So that means split them up, set them equal to 0, using the zero product property, and see your solution. So I get x equals 10 and x equals 5. And then I need to do my check. So to do my check, I'm going to come up here and it says, let's see, 10 minus 1 is 9. So on the left I get 9 to the 1/2. Does that equal 10 minus 7? So 9 to the 1/2 is 3 and 10 to the 7. 10 minus 7 is also. Here's the other check. I'm going to plug it in. I get 5 minus 1, which is 4 to the 1/2. Does that equal 5 minus 7? So 4 to the 1/2 is the square root of 4, so that's 2, and that's negative 2. It doesn't work, so that's not a valid solution. So just x equals 10. If we're going to do it the other way, we're going to take that x minus 1 to the 1/2 and write it as the square root of x minus 1, like that. So you can see all the math. I spelled it out for you up here on how to get it that way. And so you can go back up to that and reference it. So we get x minus 1 equals x squared minus 14x plus 49. And now we're at the exact same point as we were right here. So you would follow the same steps at that point. So we already know 10 is the only solution. Alright, last problem. Okay, so let's get started with the first way. So this is to the 4th power. So I'm going to raise all that. Sorry, it's to the 1/4 power. So I'm going to raise it all to the 4th power, in which to do one side you have to do to the other. So that 1/4 and that 4, because they're reciprocals of each other, are going to multiply to create 1. And so then I just have that to the 1st power. And then over here I have 7 times 4, which if you do your math properly, like I know you guys don't love doing this by hand, I do. But we have 7 times 7 times 7 times 7. So instead of doing 7 times 7 and then the 7 and the 7, I'm just going to multiply 49 by 49 and you get 2401. So 7 to the 4th power is 2401. And then I'm going to need to subtract. So subtract that 1909. You guys have calculators, so you can always either keep your brain alive and fresh by doing this by hand every once in a while, not all the time. Nobody would do it all the time. Or you can just use your calculator. I wonder which one you're going to choose. So I get 492 when I subtract. I was doing my math over here. 2401 minus 1909 is 1492, and then 6 goes into 492, and nice even 82 times. So we get 82, and then we would want to plug it into here. So 6 times 82 would give us an answer. Add it to 1909, and then take the 4th root of that using our calculator and see if we get 7. We actually do. I don't have my calculator with me, so you'll take my word for it, but in your homework problem you can try it. So just a friendly reminder, if you're going to do it the other way, you would do the 4th root of 6x plus 1909 equals 7. So when I say it the other way, all I'm saying is instead of bringing it to the 4th power with the exponent, you just changed it to radical notation first. And then you'll see right here, after those initial steps, we're back to the exact same place. Alrighty, and that is it for that unit.